Hi everyone, I'm back with another problem on projectile motion. This one is a fun one, so again, if you want to be stronger than you were at the start of the video, I invite you to pause at any time and try to make progress towards the final answer. With that being said, let's get started. Alright, so win the prize. In a carnival booth, you win a stuffed giraffe if you toss a quarter into a small dish. The dish is on a shelf above the point where the quarter leaves your hand and is a horizontal distance of 2.1 meters from this point. Figure E319. If you toss the coin with a velocity of 6.4 meters per second at an angle of 60 degrees above the horizontal, the coin lands in the dish. You can ignore air resistance. A. What is the height of the shelf above the point where the quarter leaves your hand? And B. What is the vertical component of the velocity of the quarter just before it lands in the dish? Alright, so as they drew in the figure here, in part A, we're looking for this distance right here. And in part B, they're asking for the final velocity. So the trajectory of this quarter is going to go from here initially, and it's going to go in the shape of a parabola because there's no air resistance. So I'm going to choose my coordinate system so that I'm going to choose the vertical axis here to be y, and the horizontal axis here to be x. Okay, so I'm going to start by looking for this vertical distance here. So as usual, for projectile motion, I'm going to split up the analysis into horizontal motion and vertical motion. So in the horizontal, let's see, so the starting kinematic equation is x equals x naught plus v0 xt plus 1/2 ax t squared. So v0x is the x component of the initial velocity. The initial velocity is drawn here as this green arrow, and its component along the x-axis we have to figure out using trigonometry. So I'm going to draw the triangle, the right triangle here. So this diagonal here, the hypotenuse is v, the vector, the magnitude of the vector, and its component along the, or actually I should, so there should be a 0 here to indicate that this is initial velocity, so I'm just going to put 0 here. And its component along the horizontal is v0x, and the component along the vertical is v0y. So this angle here is 60 degrees. So to get v0x, I'm going to use the cosine of 60. Cosine of 60 is the ratio of the adjacent side, v0x, over the hypotenuse, which is v, and the initial velocity is 6.4. And I can solve this for v0x. That is 6.4 cosine 60. And if you remember from trig, cosine 60 is 1/2. So 1/2 of 6.4 is 3.2. And meters per second. So the final horizontal position is going to be here, which is 2.1 meters. So for x, I have 2.1. For x naught, it's starting at 0 because that's where I chose the origin. So x naught is 0. V0x is 3.2 t. And because there's no air resistance, or there's no force speeding up or slowing the object as it moves horizontally, ax is 0. There's no horizontal acceleration, so this term is also 0. So I can solve for t, which is the amount of time that the quarter is in the air. So I can divide both sides by 3.2 here, and that's what t is in seconds. I'll use my calculator later. So next is going to be we're going to look at the vertical motion. This is the one that will give us the final, which will give us the height of the shelf. That is going to be so the quarter starts out at, or actually, let me just, I'm getting ahead of myself. Let me write down the corresponding kinematic equation in the y direction. V0yt plus 1/2 ayt squared. Right, so the final position, y, we don't know. We're just going to leave it as y. Y0, that's where the quarter starts. I chose the initial position of the quarter to be the origin, so y0 is 0. V0y, I'm going to use my, my triangle here. So to express V0y in terms of the angle and the hypotenuse, I'm going to use the sine of 60. Sine of 60 equals the ratio of the opposite side, V0y, over the hypotenuse, which is 6.4. And I can solve that for V0y to get 6.4 sine 60. And if you remember, sine 60 is square root 3 over 2, so that is 3.2 times square root 3 meters per second. So that is my V0y, the component of the initial velocity in the y direction. And ay, so the only force acting on this quarter is gravity, which is in the vertical direction. Gravity is pulling the quarter straight downward, which is in the direction opposite to where I chose my positive y direction. So the acceleration is going to be negative g. This is going to be my ay. So y equals 3.2 square root 3 times t, and then minus 1/2 gt squared. And so this is not even an equation I have to solve for, because t is given here. So I can just use my calculator to get y. So let's pull that up here very quickly. All right, so what we have 3.2 square root 3 times t, which is 2.1 over 3.2, and then minus 1/2 g, which is 9.81, and then times t squared. I'm just going to copy and paste that. squared. What do we get? 1.52. Okay. And this is in meters, right? Because we're working in SI units. 1.52. Okay, so that is the vertical height of the shelf. This is our answer for part A. Let's see, what else are they asking for? What is the vertical component of the velocity of the quarter just before it lands in the dish? Okay, so again, this is the final velocity. So these kinematic formulas that we used here are about the initial velocity. What we need to do now is look for the final velocity vector, which is something like this. It's right before it crashes into the plate here. It's going to look like that. So because there's no force slowing the quarter as it moves horizontally, the horizontal velocity is v0x. It's the same at the end as it is at the start. And the vertical velocity, oh, I'm sorry, I put v0x. That's, we're not talking about the initial velocity. So I'm just going to put vx and vy. Vx just so happens to be v0x because there's no acceleration in the x direction. Now vy, we have to use the kinematic formula relating final velocity with initial velocity, and that is this formula here, v equals v naught plus at. This is what you'll see in your textbook. And what we need to do is apply this formula in the y direction. So vy equals v0y plus ayt. Vy is what we're looking for. V0y, that is the, yes, that is 3.2 square root 3. 3.2 square root 3, and ay is negative g. And t, that's 2.1 over 3.2. So once again, let's get out the calculator. Let's see, so 3.2 square root 3 minus 9.81, 2.1 over 3.2. What is that? Okay, so that is the final vertical, the vertical component of the velocity right before the quarter hits the plate. So negative 0.895. And this is meters per second. And yeah, that's what the question is asking for. Vertical component of the velocity of the quarter, right? Yeah, right. So this here is our final answer for part B. On to the next problem. See you then.